All right. Hello, everybody, and welcome. Just taking a moment here to get everything set up. All right. So, to kick things off, we are going to be doing something a little bit different tonight. But before we jump into that, I do want to take a quick second and thank all of our supporters, because without you guys, none of this would be possible. So I'm going to start with our partners of the channel. So those are the highest tier of subscription on Patreon and YouTube. That is Caden Parker, Arslia, Garboli's Inc., Paul S., Super Awesome, and Wen Chang. I also would like to take a second and thank all of the other supporters listed here on the screen. Those are the other tiers of subscription, and also include the Twitch subs. So thank you all very much for your support on that. Of course, I would not want to leave out everybody else who is here viewing and following along with the series. Your support, just following along and interacting with the stream and on YouTube and whatnot, is greatly appreciated as well. So I'd like to take a second and thank each and every one of you as well. My camera's off a little bit here. All right, so with all that said, this is a stream about making a game engine from scratch. So it's a project that's been going for about 2 years now, and we're starting to make some pretty decent headway. We usually do 1 to 2 of these streams a week, and it actually started off as a YouTube series where we did 1 to 2 videos a week there. So we recently passed 100 videos in the series, which is pretty exciting. It's a decent landmark. And we recently implemented our scene loading and unloading, as well as being able to configure and set that up in a file. So with that said, it's been a bit since we've actually taken a look at the roadmap. And so I thought we would take a look at the roadmap, update it tonight, and pick something out of here to work on next, which I actually think I already know what I'm going to go with. TNT Master, hello, welcome. So basically what we're going to do is take a look at this, because I know there's some things in here that we've already updated. So I'm actually going to edit this. Where's the edit button? There we go. And we've got quite a few things I think that we can move from to do to complete. So we've got a done list down here at the bottom. So let's have a look here. So we have in-game object unloading, meshes, etc. That is done. So we can move that. Let's see. We still do have some container stuff here to do at some point. I may wind up doing a lot of this kind of stuff off screen. And then showing it later on, because it's, you know, I don't think you guys necessarily want to watch me write a binary search tree, right? We have multi-threading for the logging, particles, input for mobile gamepad support, string library. This is something we're probably going to have to tackle before too much longer. And that is basically having a string structure that acts similar to the standard strings that you get in C++. It'd be nice if we had something like that for higher level code. We wouldn't want to use that in our core engine code, but our higher level code, like game code and stuff like that, and editor code, things like that, could use it. So we probably need to implement that before too much longer. That may be another thing I do off camera, actually. Pool allocator, I don't think I'm going to need that yet. That's mostly going to support game code, I think. Maybe some UI stuff might hinge off of that. We do have a systems manager. And our resource system, we actually had the last to-do loader out of here. So actually, I'm going to go ahead and mark that as complete as well. Actually, didn't I already have... Yeah. The only one left was this. So I'm actually going to combine that with this guy up here. Right. Let's see. So we've got that. Binary file format for textures with converter. That's another thing we probably need to handle at some point. Resource hot reloading. We kind of already have the framework for this. We just haven't actually hooked it up. But I'm not going to mark that as done until we actually do hook that up. ECS is another one we're going to tackle at some point. Scene and level, file format, load save. That is done. So we're able to cross some items off here, which is great. Prefabs, raycasting, object picking, gizmos. None of this stuff is done yet. Audio, physics, networking, profiling. This profiling is going to be something we're probably going to have to work on sometime soon as well. Proper editor and runtime binaries to replace testbed. This probably isn't going to replace testbed. It'll be alongside testbed. Because testbed is always going to have sort of its own use, just to test new features without having to sort of integrate it into everything else. So we have UI editor. We don't have a UI system yet, so we can't do that. Game editor, logic library, hot reloading. That kind of, we're just going to do that when we go ahead and set up the editor. Key maps and key bindings, and let's see, we've got a few things here. So key maps, key bindings is done. Kvars is done. Console and console consumer is done. Console commands is done. Application configuration is done. So we can actually take this whole bunch here and move that to done. Cool. So I think the rest of this stuff we still need to do. For the renderer, we have some other geometry generation stuff that we're going to need. I'm not going to worry about that yet. PBR, we'll get to that probably sometime soon. Multi-threading support, not really a big deal at this point. Batch rendering, this is probably something we should tackle soon. Shadow maps, I definitely want to tackle soon. And then UI, of course, is kind of its own thing, so I'm not even going to really look at this all that much. Because I think the only thing we've really done out of that is the UI text, which I think we've already marked as done. Okay, so our to-do list has shrunk a little bit, which is good. So now I think what I'm going to tackle next should be kind of an interesting one. I think we're going to start looking at terrain next. And the reason for that is because I think we have most of everything we need, if not everything we need, to go ahead and generate terrain. And there are a few different types of terrain that we could work with. And the type we're going to implement is basically height map generated terrain. Now, eventually, terrain is also going to have an editor on its own to be able to edit that data, but that will probably come sometime in the future. So that'll kind of be its own line item. At least for now, we want to take a look at making terrain. So this is the one we're going to stick with. Updated roadmap for, what is it, April 2023. All right, so our roadmap has been updated. So, terrain. Let's discuss terrain. Let's see, what do I want to use to, I guess I could use GIMP to sort of illustrate some of this stuff. So just create a new image here. Oof, gotta change that background color. That's pretty rough. Just gonna draw out some concepts here because I figure this might actually make it a little bit easier to understand, I think, / hope. Let's see, where is the, I could have swore, it's been a while since I've used GIMP actually. I probably should have chosen something else. I don't want a gradient. I want a bucket fill. What is this giving me? Yeah, it's black. Why isn't it giving me black? Okay. I guess I have to just do that. Whatever. Okay. This is not a video on how to use GIMP, so I'm just going to make this work as quickly as I possibly can. All right. So when we're talking terrain, generally we are talking about geometry that is consisting of a bunch of vertices that's kind of set up in a grid, something like this. And imagine that we're looking from the sky, top down, straight down at the terrain, right? It's going to look something like this. Now, obviously, it's not going to be to scale, right? But you're going to wind up having triangles that looks something like this, right? And then each one of these quads will represent a square of the terrain. So we'll wind up generating a mesh that looks like this. And what this is going to give us is the ability to assign different materials to different parts of this mesh. So, for example, let me just draw out a few more of these triangles here. So basically, each one of these vertices can have its own sort of material information. So, for example, if we wanted to have grass, we would mark this vertex as grass, right? And this vertex as grass. And maybe this one and this one, which would make this whole thing appear as grass, right? And then if we were to switch to something else, let's say, I don't know, maybe sand, right? We'll just use like a brownish color for that. It's more like an orange, but if we were to then say, well, this one and this one are sand, and this one and this one is sand, right? What we're going to wind up with is a interpolated value between our grass texture, or our grass material rather, and our sand material as we go from this vertex to this vertex, right? And so looking at it from top down, that's sort of one aspect of how the terrain works. But then each one of these vertices, while fixed on the X and Z planes, will also have height to it. So you'll, it'll get taller and shorter. And so what that will allow us to do is kind of make hills and stuff like that. And so what we're going to wind up with is, let me actually pull up an image of it. I'll pull up a example of what we're going to be building. We'll wind up with something that looks kind of like this, right? Where we'll have a bunch of these triangles that each one of these individual vertices has its own height. And then we just have sort of a rolling terrain, right? And so the way that we do that is we use something called a height map. And a height map basically looks a little bit something like, let me grab a good example here. A little bit something like this. So it's typically a black and white image. And the whiter the pixel is, the higher value on the y-axis is. And then black obviously would be a 0 value. And so you can use this to interpolate the height along the y-axis. And that would give you that sort of rolling terrain. And what you do is you basically, when you're working with height maps, you tie one pixel's value is one vertex on your terrain. So this is a pretty large image, so this would wind up being a massive, massive terrain. So we probably won't start off with an image quite this large. We'll probably start off with something much smaller. But the idea behind a height map terrain is that you can use this to very quickly sort of paint what your terrain is going to look like, at least as a starting point of what you might want to generate. And so that is going to be the easiest way for us to get a terrain up and running. And then generally you would take a height map generated terrain and you would paint textures on it and you would edit it from there. You think my microphone is clipping. Is it too hot maybe? Let me see. Yeah, it might be a little bit. Yeah. Let me try backing that off a little bit. Is that better? Does that sound a little bit better? I recently changed microphone stands, and so it's kind of in a different position, so hopefully that's better. I hope it wasn't that way last night. Okay. Hopefully it's not clipping. I'm not seeing it go into the red here, so hopefully we're good. Okay, so this is basically what we're going to wind up implementing. Is we're going to implement a terrain, but that terrain is going to be based on a height map that we import. So there's no way in heck we're going to get all this done in one night, for sure. It's going to be a multi-part thing, but I think that's fine, right? So the first thing that we actually have to do is we probably should start on I'm thinking the geometry portion of this, because reading the height map is relatively easy. Generating the geometry will probably take a little bit more doing. Not that it's hard, but just to get something sort of in the game. So I hope that makes sense. If any of you guys have any questions about that, feel free to jump into chat and ask away. But in the meantime, I'm going to go ahead and get started on that. So one thing I do want to look at really quickly is in our, I think it was in backend. When we create a buffer, let's see. I don't recall if we had assumed that the topology is going to be a triangle list. So this might be something we have to change. So I'm not going to worry about it for right now, but probably as an optimization, we're going to want to change that. So right now what we have is in our pipelines by default, we feed it a triangle list, right? So we have a triangle here, a triangle here, a triangle here, a triangle here. And another version of that is a triangle strip. So I think it's VK primitive topology triangle strip with adjacency. I'm not sure what the difference is between those two. But a triangle strip can save us on some of the data that we need to pass. So since we know that this is going to be a flat grid, a triangle strip might be the way to go. But for right now, I'm going to start with just regular topology. But that is something we're probably going to have to touch on. So we may have to make some minor modifications to the Vulkan pipeline. All right. So let's go into, let's collapse some of these things first off. We'll go into resources, and we're actually going to have to create a loader for this too, I'm just thinking. But I'm not going to worry about that initially, at least. The other thing that we're going to have is we're going to have a terrain binary format. So the height map generation is really going to be more of like an import thing. And then we'll generate our terrain data off of that. And then when we go to serialize that or save it, it'll be in a binary format. I think that makes the most sense. When you've got the windows, swap chains, synchronization sorted out, do you find Vulkan hard to work with? The initial setup seems daunting and verbose, but I don't know if that reflects day-to-day usage. So I have found, for the most part, that once you have windows, swap chain, synchronization, and I would also say graphics pipeline looped into that, and all the stuff that goes into that, I would say once you have all that sorted out, it's really not too bad. Adding things to it is really not too bad. Once you get past that sort of initial push and all of the stuff you have to set it up, it's really, really not too bad. It's certainly a lot more than OpenGL, but from what I understand, it's pretty similar to DirectX 12. I haven't touched DirectX 12 yet, but that's pretty similar to Vulkan from what I understand. But yeah, once you get past that point, it's really not too bad. So I'm thinking the amount of actual Vulkan work we're going to have to do is going to be pretty minimal for this, actually. All right. So these are the loaders. I'm not going to do that yet. I'm going to call this terrain.h, and we're going to pragma once. Whoops. And we're going to include defines, of course. We're going to include math types. And I think that's actually all we're going to need, I believe, for this. So the first thing we're going to do is we're going to type def a structure, and we're going to call it terrain. Right? And within that, we are going to define a few different things. So, like a lot of other things, we're going to want a name. We're going to want a, you know what, actually I think the transform type is there. We're going to need a transform. So I'll call this xform. We are going to need to know basically how many units wide and how many units, I don't want to say tall, I guess long. So we'll say length by width. I'll say U32 tiles. Do I want to say tiles? Yeah, I'll say tiles wide for now, because that's kind of what they are. U32 tiles long. You know what? Let's just call it what it is. Tiles X and tiles Z, right? We'll also probably want to, because I don't think transform has this. We're also going to want to keep some extents. So we're going to want to keep vector3. Actually, don't we have? Yeah, we have extents 3D. Extents, which should just be 2 vector3s, min and max. So we're going to need that. And that's for rendering purposes. We'll also need vector3 origin. And that's for when we generate the geometry. And all of these things will also, of course, be transformed by the xform here. Let's see. So the next thing that we're going to need is the actual data itself. So what does the terrain data look like? So we are going to define a new vertex type, because the vertex type that we have doesn't really cut it. So if we look at vertex 3D, it has position, normal, texture coordinate, color, and tangent, right? But that's not actually going to be enough information for us. This is enough for normal geometry, but if you recall, on my little graphic here, we've got a few other things that we need. So we need something like a material ID to say, okay, what material out of an array of materials is this using? And we may need some other things, like whether or not this particular vertex should even be rendered, because maybe some of them we want to have like holes in the terrain. And so maybe it shouldn't even be rendered at all. So I probably won't put that in right away. We could probably add that later. But what I'm going to call this is type def struct. I think I'll call it terrain vertex. Right? And this is actually going to have a vertex 3D. Actually, I don't know if I want to do that. We could technically paint a color in addition to the texture. I think what I'm going to do now is I'm just going to duplicate this for right now, because I'm not sure that we're going to keep all those properties. But the other thing that we're going to need is, I'm going to say a U8, because we're not going to have a lot of these. And it's going to be material index, not to be confused with a material ID. So a terrain is going to hold a certain given number of materials. It's going to have a max number of materials, and then this index will be one of those materials. So in this case, we're going to have brief the index of the material from the terrain's material array. And I think that is probably going to cover it for right now. I think there's going to be more information that I'm probably not thinking of right now, but we can definitely add to this as we go. So the terrain itself is going to have, we'll say a U32 vertex count and a array of terrain vertices. And of course, since we're going to have vertices and we're going to be rendering triangles, we're going to need to have indices too. So I'll say U32 index count and U32 array indices. And I need to make this an array. All right. We're not going to use the D array for this because we don't really need to dynamically change it. We're going to set it once, and that's going to be it. We're not going to resize terrains. It doesn't really make sense to do. Okay. So the next thing that we need to do is we need to have an array of materials. So if we look at the material system, let's have a quick look at these materials. So right now, materials hold a diffuse color, a diffuse map, a specular map, and a normal map. And while I think this is fine initially, I'm not 100% sure that we are going to have a one-to-one relationship between terrain materials and actual materials. Because we might not want our... We may need extra information, or we may not need the same amount of information for a terrain material as a regular material might have. So I'm thinking this is probably going to be an offshoot of a material, which means that we're probably also going to have to modify our material system to have a material type, perhaps, that deals with this. So I think for now what I'm going to do is I'm going to duplicate most of this logic, which I know sounds terrible. And then if we need to combine some of it later on, we always can. But I don't necessarily want to kind of paint ourselves into a corner, right? So we have our terrain vertex. We're going to type def a new structure called terrain material. And for now, it's going to have the exact same things. Texture map. Where does texture map? Where is that defined? That is in resource types. Okay. So we'll need to include resource types. Okay. Yeah, I think that's the way we're going to do it for now. And what I'm thinking is each terrain will be responsible for sort of dealing with its own materials. We might still go through the material system. I haven't fully decided yet. But the terrain is ultimately going to own its materials. This does mean that between terrains, there's not going to be sharing of materials between terrains if we do that, though. It's kind of a tough call to make, actually. But I think for right now, it's going to be the right call, because I have a feeling that we're going to need these to be handled completely differently from one another. So we will have an array of materials and a count of materials. Material count. All right. So basically, this material index here will index into this array. And then these guys are owned here. So our terrain will have, here's the geometry data, the material data. What else? It's got a transform. I think this should probably be enough to get going for now. So let's go ahead and stub out some of our methods for it. So we've got B8, terrain, create. And all we're going to do here is we are going to take in a U32 tiles X, U32, actually, you know what, I'm going to say tile count X, U32 tile count Z. We're just going to assume an origin of 0, 0, 0 and an identity transform, and then generate based off of that. So based off the X and Z, we'll know how many of these things we need to generate. So that should be all we need, except name. And we'll make this constant. So then we'll say terrain, pointer out terrain. All right. So that is the creation of a terrain. Obviously, we'll have a void terrain destroy. And that is just going to take a terrain. We'll call it T. Now we want to make this follow the same paradigm as some of the other objects. So actually, we should probably be putting this stuff in a configuration object, come to think of it. So let's type def a struct called terrain config. Terrain config. And I'm just going to copy straight out of here into terrain config. Right, and then we're going to have a terrain config passed in. Should we... I don't know if we should keep a copy of the configuration or not. For now, I'm not going to. I'll keep it if we need to. All right, so we have our create, destroy. So create doesn't really do much except, oh, you know what? We have to keep the config if we're going to stick with this. Because otherwise initialize is not going to know what to do. So we'll keep a copy of that. Then The next one will be B8 terrain initialize, and of course this is going to be terrain T. We need terrain load, terrain unload. I'm going to add a terrain update. Why? Because once we have an editor in place, if there have been changes that have been made to the topology, the update is where that change is going to be cemented in place in terms of updating geometry. So it's not something we're going to use right off the bat, but we're going to scaffold it anyway. We need B8 terrain render, and that's going to take the terrain. I think we can take a constant pointer to that, actually. Frame, oh, you know what? We don't have frame data. So include resources. No, it wasn't resources. I think it was it core? Core frame data. Frame data. P frame data. All right. And actually this render is probably going to be more of a render packet generator than anything. So we're probably going to wind up modifying this. For right now, I think I'm probably just going to draw it and then we'll refactor it later. So that's going to be changing. I think that's all we need though. I think that's all we need. So we'll go ahead and create the C file. And of course we'll include terrain.h and get all these things stubbed out. I just thought of something else we're going to need to do too. We're not going to be able to access this in game code without exporting these things. So let's do that. Okay. All right. So first things first, if we don't have config or we don't have out terrain, then there's not anything we can do, so we're going to boot out and return false. Let's also include, can't spell tonight, core logger. Okay, error. Terrain create requires valid pointers to config and out terrain. All right. If we get down here, we'll return true. We are going to say out terrain config equals config. We're just going to take a copy of that for right now. Oh, you know what? Our config actually isn't even a pointer, so we don't need to check that. What am I doing? Requires a valid pointer to out terrain. Okay. So for here, I think we'll just take a copy of the config, and then we'll also include core k-string, and we'll take a copy of the name, right? So out terrain name equals string duplicate config name, right? So we'll have a copy of that. Let's see. I suppose we could do... Man, we should probably leave everything else for initialize, actually. Yeah, I think I'm okay with that. We'll fill out destroy in a bit. Fill me out. All right, so initialize. Obviously, if not t, k error, terrain initialize requires a valid pointer to a terrain. Return false. And we'll return true down here, just for good measure. Okay. So at this point, this is where we can stand up a lot of the arrays and stuff like that. We don't necessarily want to load any graphics at this stage, but we can at least acquire the memory that we're going to need to perform the load. So we can also validate that the configuration is valid. So we can say if not t config dot tile count x k error tile count x cannot be less than 1. Return false. All right, so we can at least do some sanity checking here. Do the same thing for y. Okay. So we've validated that both of those things are good. Whoops, it's not y, it's z. Sorry. That should be z. Okay. So we validated those. Now we can say terrain. We'll do vertex count is equal to t config tile count x times t config tile count z. And I think actually we need t tiles x is equal to this guy. And we'll save off the z as well. Right, and so actually, you know what? I want to rename this, because tile z is kind of not really descriptive. We'll say tile count z and tile count x, right? So actually we could just use the tile count straight off the terrain itself here, shorten that up a bit. We need include core k memory .h because we need to k allocate our array. So the size is going to be size of terrain vertex times t vertex count and mem tag array, right? And then this is going to be t vertices is equal to that. I think I've got that right. Yep. All right, so that is the vertices. And for now, since we're using a triangle list, let me think. We actually need to, let me look back at my image here. So now that we're doing this, I think we're still going to wind up with, it's going to be vertex count times 6, I think. That seems right. Because we're going to have, yeah, I'm gonna roll with that for now. That might be wrong. We'll find out if it is. So index count equals t vertex count times 6. And of course, we need to allocate an array for that. So we will do indices size of u32 times index count, and then memory tag array. Okay. What else do we need? So we need to set up the transform, which we probably should add to the configuration eventually. The extents, the origin. I think that's it. Oh, the material count. Okay. So let's actually do the transform here. So t xform equals transform. We don't have transform in here, so this is going to include math transform transform create. That'll just give us an identity transform, and then the extents is just going to be, I think we can literally just zero the whole thing out. We'll just cast that to extents 3D. Okay. What else? Oh, the origin is vector 3. Do we not have, we don't have kmath either, do we? Nope. Include math kmath. Vector 3 0. So that's the origin. The extents we're actually going to have to figure out. Oh, there's something else I didn't think about either. So there is something we're going to have to add here. So we know how many tiles we have, but we don't know the scale or the amount of space in between those tiles. So they could wind up being really, really big, or they could wind up being super compressed. And generally, like at least in this engine, I'm targeting like 1.0 in space is going to be about a meter, we'll say. And so it's probably going to be some fraction of that, because a meter for 1 square of terrain is kind of large, I think. So we should probably add 2 new things here. We're going to say F32 tile. Do I want to call this scale? I guess that makes sense. Scale X and scale Z. And we'll just, how large each tile is on the X-axis. And the Z-axis. Keep wanting to say Y. All right, so the tile scale, that probably ought to be in here as well. So we're going to add that here. So that's definitely a configuration thing. Yeah, so we'll do that here. So we'll say t tile scale x equals t config tile scale x. And then we'll just do the same for z. All right. Okay. So the last thing we need to do is hook up our materials. This is also kind of a configuration item, because theoretically what we should eventually wind up with is something very similar to what we have for our regular materials, which is these KMT files. And so we should probably, these material files don't really have a type. So we should probably modify that to accept a type, right? Because we could use the same loader for that at least. Maybe. I suppose if it branches off a type, we could. Trying to decide if I like that idea or not. All right, I think I'm gonna roll with that for right now. Do we have... This is our material config. So I think I'm actually going to use this directly in our terrain config. So U32 material count and material config, material configs. So that means, I mean, that is going to kind of complicate our loader a little bit, but I think that's going to be okay. It technically means that we're going to have two different types of configurations is the way I'm envisioning it. So our terrain config that we load from file will probably have these material configs just named, and then that name will be used to look up the actual KMT file. I guess I could put that in here. So material count, and then I guess I could just do a double pointer, right? Material names, I guess. So technically this will be loaded from, this will cause file loads to happen. Obviously the size of these two arrays will match up, and then we'll have material configs loaded. At least that's the way I'm envisioning it right now. Okay. So for right now, we'll say T material count equals T config material count. T materials equals K allocate size of material config times T material count. So that way all that stuff is set up and ready to go for when we load it. We need a memory tag array there. All right, I think that's going to do it for initialization for right now. So now we can talk about the load. And I think the way that I'm going to approach this is, by the time we get to this point, we should already have all the data in place. And then we can tell, based off of what data we need to get to this point, and the render and update and all that, what we need to put together as far as the loader is concerned, and then we can kind of work it backwards from there. In fact, now I'm thinking we don't even really need these material configs, I don't think. Really all we need is the names. We could just look them up by name and then check their type. Yeah, I think I'm good with that. All right, so right, this is the actual materials though. So I am going to need technically pointers to materials. Array of pointers to materials. Because the more I think about it, the more I think the terrain probably shouldn't own the materials. The material system should own the materials, even though it's a terrain material. So the material system is going to be a little bit aware of this type of material. I suppose I wish we had a way to like add metadata to our materials. And maybe that's the real solution here. Maybe we need some sort of way to be able to add additional properties without adding it for all material types. Yep. I think that's what I'm going to do instead. I know I've kind of gone back and forth on this a few times, but I think I'm going to stick with standard materials here because that's going to make this quicker to implement for one thing. Because if I just do that, then loading this will be easy. And if I have to expand it later on, I can always figure out how to do that. Maybe I could do it through a union or something with the various properties. Or maybe I could have some sort of extension structure, sort of like what Vulkan does with the pnext pointers. Maybe that's a way I could do it. All right. Okay, so this is kind of what our terrain is going to look like. So whenever we go to load it, this is where we're actually going to generate the geometry and the indices and all that fun stuff. So I think the way that we're probably going to do this is we're going to loop along the Z axis and then the X axis. So if we think about it in those terms, right? Just imagine this as the Z axis, right? So this is Z, and this is your typical X axis, right? You're going to want to iterate starting at the row and then go across, this way, and then this way, I think. At least in terms of generating the individual vertices. Because we don't really care about the triangle triangulation until we actually get to indices. So I think that's going to make the most sense. All right, so let's get the stupid stuff out of the way. So if not t, k-error, terrain load requires a valid pointer to a terrain. Ya dingus. Return false. All right, and then of course we'll have our return true down here. Posture check, okay. Was my posture bad or something? Probably is. Posture check. All right, thank you for that, Redeem. All right, so I think the first thing that makes sense is we'll go ahead and generate vertices. So we'll say for U32, we'll call this Z equals 0. Z is less than T tile count Z, Z++. And then in here, we'll say for U32, X equals 0. X is less than T tile count X plus X. All right. And then we're also going to keep an I for the index or the position into the array. So we'll say I also equals 0. And every time we increment this inner loop, we're going to say ++I as well. That way we have both our X and Y position, or our X and Z position, as well as our position in the vertex array. So at this point, it's basically just some quick multiplication, right? So we'll say, we'll generate a new terrain vertex. So we'll get a pointer. We'll say V equals T vertices sub I, and we'll want the address of that. I'll just make it a little easier to deal with there. And we'll say v dot position dot x is equal to is equal to x times t scale x, tile scale x. And yep, that should be right. Okay. And then v position z is equal to z times t tile scale z. All right. And what we're going to do for now is v position y is going to be equal to 0.0f. This will be modified by a height map, right? So when we go to create a terrain based on a height map, we should also have a value to plug in here. But since we don't, we're just going to use 0 for now and generate a flat plane. So we'll do that. The v, let's see, color we'll just set to I don't know, vec4 1, right? We'll just default it to white for now. V normal for right now, I'm going to set to vec3, and we're going to say 0, 1, 0. I might have that backwards. No, I think that's right. So that's our normal, our texture coordinates. So texture coordinates, that's actually going to be something I do need to think about. So, whoops, let me pull up this one more time. So if we want our texture to tile, we basically should be 0 here, 1 here, and then we can tile it and say 2 here, 3 here, 4 here, and so forth. And that should give us a nice tiling terrain. So all we should really have to do is say it's just x, right? So texture coordinate dot x equals, we'll cast it to an F32, x. And the same is going to be true for y, because our textures are basically going to start and end at those vertices. That needs to be z, rather. Yep, okay, that seems correct to me. So what else do we have in here? So material index, I guess I'll just set to 0 for right now. This is going to be another thing that is I guess when we're generating from a height map, we're not really going to have a concept of that, right? So we're always going to set it to 0, and then when we go to write out the binary data of this, then we will handle it that way. And you know what? This doesn't even belong in load. This belongs in initialize, and I'll explain why. Because by the time we get to load, the geometry should already be known at that point, right? Whether we generated it this way because of a height map, or whether we loaded it from a binary file, we should probably read in the configuration at this point and at least load up the geometry. Not upload it to the GPU, but we should at least have this information by this point, I think. That way, by the time we get here, all we have to do is send it to the GPU. So I think that's the way I'm going to do this one. It just makes sense to me on the surface anyway. All right, so we have color, we have normal, texture coordinates, position. The only thing we're missing is tangent. We need geometry utilities for that. And geometry utils, I think, did have... Yeah, so we can generate tangents based off of vertex 3Ds, which aren't exactly the same as what we're dealing with now. The data is the same. But we can't just cold cast that because these structures may differ in memory structure at some point. So I may actually have to make another copy of this, specifically for terrain. And this one too, because we're actually going to want to use generate normals when we actually load a height map. Okay. I'm going to have to think about that for a bit. But we're probably not going to get to that point tonight anyway. So I'm not too worried about that right now. Worst case scenario, we'll have a duplicate function. All right, so for now, I'll just say tangent equals vec3, 0, I guess. Obviously wrong. Yeah, and then this needs to be based on geometry. So probably what we'll wind up doing is we'll generate all of these. We'll have to actually generate all of these because we need the position information to actually generate these things. And then we'll have to make another pass at it to actually generate those things. So for now, I'm going to leave that as is with these to-dos in there. Once we have something rendering in the scene, we'll move on from there. Okay, so that's our vertices. The next thing we need to think about is our indices. So go back to our picture here. And the way we're going to need our loop to work is we basically are going to need to go in a loop something like this. So we have this one. We'll do, I thought that was a larger. So we have this one, and then this one, and then this one. And then we'll probably start from this one again, go to this one, and then this one. And then we'll repeat that here, 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 something like that. So if we consider these as offsets into the array, the ones that are along this are easy to figure out, right? So it's going to basically be 0 and then 1. But then this one here is a little bit more complicated to figure out, right? Because you don't have to actually go all the way to the end of this and then flip around. So technically, this next one is going to be, you know, width. Sorry about my terrible handwriting here. And then plus wherever you're at. So in this case, it'd be width plus 0, right? And then it would be this width plus 0 again, 1, and then width plus 1 is the way that I'm thinking of generating that. So generate indices. In this case, I think just well, let me think about this. I think just the number of squares should actually do what we need. So the number of tiles. So for U32, U32I equals 0. I is less than T. Do we have vertex count? I don't want to use vertex count. I just realized I've actually calculated something wrong here. This number of vertices is actually going to be wrong. This needs to be, vertex count needs to be tile count times, tile count x times tile count z times 4. Because we're not going to have one vertex per tile. We're going to have 4. I think that's right. I'm not 100% convinced. Yeah, I think that makes sense. Although technically it's not always 4 either, because we're going to be reusing some of these vertices. So that's actually not correct. It's going to be I think we're going to wind up missing a row here. I think we're going to have to add on for another row, but we'll cross that bridge when we come to it. So I guess we'll go with vertex count for now, and then plus plus I. And then what we'll do is we will offset into the array of indices based on this I, and we'll just multiply as we go. So in other words, our first one will be U32 index, I'll say V0 actually. No, we don't want to say V0, we want to say I0. I0 is equal to just going to be I itself. And we might actually need the X and Y for this. Because otherwise, well, yeah, let's copy this actually up here. Let's keep it simple. Let's do, we'll go with tiles like this, because I think that makes the most sense. So, U32 I0 is going to be equal to Y times T tile count X, so that's the width, right? Plus X. All right, so that'll get us the offset into the array for the current row. I keep saying Y, that should be Z. And then the next one, index 1, is going to be this plus 1. And then the third index is going to be one row down. So index 2, this is going to be z plus 1, which means we're going to actually go outside the bounds of this array at some point. So we probably need to say -1 on both of these things. Because we are plus 1ing, we don't want to overflow the array there. Okay, so that should give us that one. Yeah, let's call these V. And then V3. Right, so this is the index of the vertices, basically. That is what we're getting here. So we have z plus 1 times tile count x plus x plus 1. This one should not have the x plus 1. That should just be x. Right. Okay, so what that should give us is basically these 4, right? Okay. So what we'll need to do then is our pattern is going to be V0, V1, and then we'll say V2, and then V2, V1, and V3. That's going to be our index pattern for each one of these grids, grid spaces. So at this point, we will say T indices, and this is going to be I plus 0 is equal to V0. Right, and I'm just going to paste a few more lines down here. +1, +2, +3, +4, +5, right? And then all we have to do is just follow this pattern. So we'll say V1, V2, V2 again, V1 again, and then V3. All right. And let's see. So at this point, instead of ++I, we should technically be doing I plus equals 6, right? Because that's how far we're moving in the array. And then for each one of these, should we duplicate vertices? I don't think we... No, we won't be duplicating it. So we'll move on. So the next version of this will be here, starting here, basically. So we'll just move one forward in the array. And then it should be relatively the same thing. So that should get us all the way through the array. I think that's correct. So that's the indices. All right. So let's see. What else do we have? We have our materials, which I'm not going to worry about that for right now. Okay. So I think that's our geometry. Cool. So now comes the loading portion. By the way, if you guys have any questions on this, feel free to ask, right? Or if you noticed something that I've done wrong, feel free to call it out. All right. So I guess the next thing we're going to need to do is like load up the geometry. Raticide, hello. How are you? Let's see. I think in... I probably could have copied some of this code, actually. You do game dev for a living? I have in the past. I currently don't. I do develop in 3D for a living right now, but it's not game related. But yes, I did in the past. Let's see. We should... I think we actually created a job for this in the past. Create draft. Well, we didn't for this one, so I suppose I could do. I'm trying to decide if I want to reuse this or not. I don't think I can, though, because well, let me look at the Vulkan backend for a second, because I don't fully remember. Create geometry. So we have the vertex size and the vertex count, vertices. So it does look like we left this open-ended. So I think this is actually using Vulkan geometry data, which I think is open-ended. Yeah, so it doesn't actually, it's not bound to actually using geometry. Which is good, actually. I'm now thankful I did that because, oh, wait a minute. Womp womp. Why do we have a hard-coded size of vertex 3D here? This is only used, and we've got a hard-coded index element size. I wonder if that's left over from when we initially put it together. We should be using these. Like, we have vertex size and index size, and I think we've been getting away with it because the only type of geometry we were using was vertex 3D. This should be vertex size. Yeah, and then index size. I'm glad I found that. Your code is full of crap like that? Yeah, I know what you mean. Yeah, I've tried to get rid of a lot of it. Like, early on in the series, when we started this, like, I hard-coded a lot of stuff just to kind of get things up and running. And every once in a while, I still find something like that I hard-coded, and I'm like, I never got rid of that. Okay. And you know what? That is just enough of a nasty change that I'm going to, before I continue any further with this, is I'm going to build that. Stub these out. I'm going to build, and which one? Oh. I'm going to test that real quick, because I am not just going to rely on blind faith that that's going to work. It should. Okay. It looks like we are good. All the lighting information is correct. The normals are correct. Okay, so I think we're good. All right. Those kind of changes are kind of scary. Yeah, it looks sweet. Yeah, I picked some decent test assets. I actually need to really get some new assets. I just I need to find some that are like freely available that I can use. That's one of the reasons I'm starting to do a terrain, because I'm kind of bored of looking at the same thing over and over again. So at least with a terrain, I'll have something else to look at, and then maybe we can put water next to it or something. Start making it look kind of sweet. Okay. So we have all of this. So I think all that I really need to do is just this. Render or create geometry. Does geometry... Let me see something. That has extents. It has a material. Okay, this is open-ended enough. I think I can actually use geometry as it is. So I need to add that actually to my terrain. So we need to hold geometry there. Geometry config. Do I want to loop that through this geometry system? I don't think that I do. I think I want to handle this on my own. Acquire from config. All right. So I think actually what I'm going to do is I'm just going to take a copy of this and make it fit what we actually need. So geometry pointer we're going to say is from T geometry. We're going to take the address of that. I think I might just size of geometry. Zero that out to be safe. I don't think I actually need any of this stuff. Don't need this because I'm not using the geometry system. Create geometry just essentially does this. So back that out. And let's see, we don't have the renderer, do we? Oh, do we? Oh, wait, what am I doing? I just pasted that in the wrong place. Terrain, not there. That was close. Okay, so vertex size, this is going to wind up being size of terrain vertex. The vertex count is going to be T vertex count. Then we have T vertices. Then we're going to pass in size of U32. For the index size, T index count, and T indices. All right. So that'll get sent off to the renderer. We don't need any of this stuff. That was for the geometry system. The center and the extents, we already have those in the terrain. I think we called it origin there, though. We might want to rethink that. T extents min. And T extents max. All right. I'm just going to take an ad break. I just noticed ads are rolling, so I'm going to take a break for a second here. I'll be right back in a minute. All right. So, one thing I noticed is the G generation is being incremented there. That actually needs to be set to invalid ID here so that we don't try and render it before it's loaded. That would be bad. Okay, so acquiring the material. So generally speaking, a geometry has one material assigned to it. But this geometry is going to have multiple materials assigned to it. And so we might actually have to extend the way that this works a little bit. We're not going to be able to send it through our typical geometry render pipeline, I don't think. And the reason for that, backend. Is, well, technically, actually, the answer isn't even really here. It's in the material system. So we have the material system apply local and material system apply instance. And all of this stuff is pretty specific to the way that the standard material shader works. And for a refresher on that, if we take a look at some materials here, a single material has these properties, right? So it tells us what shader we use, and then these are its properties here. The ones that matter are here. Problem is we're going to have multiples of these being applied at once. So if we have a look at our shader itself, we have this built-in material shader here. And we have, where is that? So our samplers are here, right? And then our material properties themselves, like the shininess and things like that, diffuse color, those are in our local uniform. The problem is going to be we're going to have multiple sets of these, right? Because we're going to have multiple materials, which means that we're going to have a bunch of samplers. We're going to have a bunch of diffuse colors, a bunch of shininess, right? And so the way that this particular shader is structured is just totally not going to work for us, unfortunately. And so this is probably where most of the work is actually going to reside. It's not going to be in the geometry generation. It's going to be here. Because obviously we're also going to have to come up with a shader config for this as well, which looks like this. So for those of you who haven't seen this portion of it before, this is basically how we tell our graphics pipeline what our shader is expecting. And so we'll need to come up with a new version of this for our shaders. So our vertex attributes are going to be largely the same for right now, minus the additional material ID that we're going to have in there. Our uniforms are going to be where it's different. Our uniforms and our samplers, which is right there. So I think the only thing that is, you know what, there is one thing that's actually bothering me, and it's been bothering me for a while. So our samplers, our shininess, our P lights, all of that, all of our lighting data is all on the instance level, not the local level. But in the shader, it's actually called local, and that's confusing every single time I look back at it. I think, why did I name it that? And what a dingus, right? So I'm going to rename this to instance uniform object. Whoops, I thought I had that on rename. I'll just do it here. Instance. Right? And then object UBO is used in a few places. So instead of calling that object UBO, I'm going to call that instance. Because we used to have, that's a leftover thing from our old, the old way we did it. Oh, I did it again. Should be object UBO, and we want to replace it with instance UBO. Right. Okay. So let me just post build that real quick. Task, post build. Make sure I didn't screw anything up. I know this is probably not the time to handle that, but it was bothering me. So when we start thinking about our new shader, we're definitely going to need to have that straight. So I think what I'm going to do actually is the vertex shader is largely going to be the same. I don't think there's anything in this that's actually going to change. So I technically could use this by itself, but I'm not going to. I'm going to create a new file, call it built-in terrain shader dot vert.glsl, right? And this is going to just be the same. That's fine. Like I said, most of the work is going to be in the fragment shader. So I'm going to copy this anyways, even though we're going to be changing it up a lot. And I'm going to create a new shader file. So we'll call this built-in dot terrain shader dot vert dot frag dot glsl. And we're going to start on this and then kind of work backwards from there, just so we kind of understand the data that we're going to have to deal with here. All right. So we are going to have a bunch of samplers for one thing. And so right now we have this sort of array of sampler 2Ds, right? And then we index into them by this. That's not really going to work for us this time around, because we're going to have a set of those per material. So I guess what we need to really figure out is what is the max number of materials we're going to support going to be, and then go from there, right? Because we can't just have dynamic arrays in here. That doesn't work. So I am thinking, I want to say 8, but I'm feeling more like I should lean towards 4. And this will just be how many different surfaces we can actually have in a terrain. 4 doesn't feel like enough, though. I feel like 8 is probably a good number. I just wonder if we're going to hit issues with like sampler counts and stuff. So this may introduce some issues on people's machines that may not support what we're doing here. So that should be interesting to see. I think I'm going to go ahead and pull the trigger and do that anyways, though. So there's a couple ways we could actually tackle this. Thinking about it now. Technically speaking, if we think about how these materials could potentially interpolate, let's say, for example, we have, I hope that blue shows up. Let's say that we have a, I don't know, we'll use this center one, right? So we have one material here, and then we have, I don't know, another different one here. Then we have yet another different one here. Right, I'm just color coding these to kind of make it a little bit clearer as to what we're talking about. So we have another different one there. And then we have yet another one here. And then we have, make these buttons so small. Another one here. And just a couple more. So let's see, what haven't we used? Green, I guess. Dark green, maybe. Dark blue, we'll say. So we've got another one here, right? And then I guess we'll use white for another one here. And then, I don't know, I guess we'll use this color for here. All right, so this is kind of the worst case scenario where we have 9 different materials on a single terrain, right? And this is even beyond what I'm thinking of supporting. So the real problem here is, what is the max number of materials that we're ever going to have to blend between? And ultimately, that's kind of what we have to figure out, I think, because theoretically, we would only ever have to have that many materials bound at once. So what I mean by that is, let me see if I can find yet another different color here. We'll go with like super bright red. Whoops. Why did that zoom out? Stop it. Okay. So what I mean is, this vertex here can potentially blend with this one, or this one here, or this guy here, or this guy here, or this guy here, or this guy here. Basically, wherever there's a line going to another vertex, that's the ones it can blend with, right? So right off the bat, that means that this one and this one do not need to be considered, right? And so realistically, the only ones we'd have to worry about blending would be, what's that, 1, 2, 3, 4, 5, 6, 7 textures at once. So there's 7 materials at once. So actually I think 8 will work, because we'd only need to have, or actually we'd only need to have 7. Only 7 ever bound at once. So that may actually be okay, now that I think about it. We could just figure out, based on, I guess we'd have to write a few utility methods to figure out how would we actually be able to figure that out? No, that actually doesn't matter, because I was thinking we could just draw all the vertices for a particular material at once, but that's actually not going to work. We are going to actually have to have an array of all of these materials. The only thing that this is really going to affect is how many materials we have to take into account based on weights, essentially. So technically speaking, we probably should be storing weights of materials on each one of these. Because we could use that as a blend factor between, like, as we transition from one to the next. Maybe. Yeah, because how else would it know what to mix with? This is an interesting problem, actually. So I feel like there's a bunch of ways to skin this cat. I'm just trying to figure out what the best one is. I think I'm going to keep it simple for now, and we're just going to bind all the materials, and we'll have a weight factor on each vertex, And then based off that weight factor, we will blend the material or mix the material in by that amount. And all those weights should add up to 1. And I think if we do that, we should have a pretty stable system. Does that make sense to you guys? Makes sense to me on the surface. I think that's what I'm going to go with. So we do need a little bit more information then. So I'm going to go back to, let me close some of these other things. We don't need these. Material type I'll keep open. So let's go here. We have our vertex structure. So we actually have a material index, which now that I'm thinking about it, is probably not what we want to do. We should probably instead have a F32 material weights. And then this is going to be a collection of weights, material weights for this vertex. And then do we do a weight count? I feel like that's, do we do a weight count or do we just say 8? I think I'm going to keep it simple for now. I'm going to pound define terrain max material count 8, and we'll use that. And we'll just make our shader match that. So this is kind of where we're stuck, right? Is like acquiring our materials, having somewhere to store them. We are going to have to make some changes to our create geometry to support multiple materials. So maybe our geometry, instead of just holding a single material, maybe it's like maybe we have a multi-material geometry, and maybe that has weights as well. In fact, that's probably what we'll have to do. So this material would basically become an array of materials, an array of weights. Well, I don't necessarily want to pollute our basic material system with that, because 90% of the time that's not going to be needed. So maybe we have a separate property, right, with like a type that we can branch on. Things to think about. All right, so let's go back to the shader for now, and we'll start thinking about this a little bit. So our samplers basically is going to have to be 3 samplers times 8, right? Because we are going to have a const int max terrain materials, and we'll set that to 8, and actually we'll just do this. Now, one potential optimization we could do with this is we could define like a multi-material that, instead of having like all these materials separate, the materials and their maps are combined into like a single texture, and then we sample based off of that. And that would reduce our samplers by a factor of 8 in this case. And then all we would have to do is adjust the UV coordinates. Maybe that's what we should do. Maybe we should have a multi-material. Because if we had a multi-material, then we could largely keep this code the same, actually. At least as far as this is concerned. We'd still have to have multiples of this and this. But it would cut down the amount of data here. It would just make it a little bit more complicated to load. I guess I could switch it to a multi-material later. Yeah, I think that's what I'm going to do. And instead of using these constant ints for array indices, I'm going to treat them as multipliers. So they're going to be 1 indexed. And that'll allow me to say, okay, well, for material ID or material slot 0, give me, well, actually, these should probably be offsets, shouldn't they? Not multipliers. Which could be 0 indexed. So I'm going to rename these just so that it's obvious as to what they are. They're not meant to be used as direct indices. They're meant to be used, take the ID, and then multiply it by the length, and then add these offsets. That makes sense. Okay. All right. So we're getting kind of close to where we're going to wrap up for the night. So I think what I'm going to do is I'm going to take some notes down here in our structure, just so that we don't lose track of kind of what we were thinking, right? And then next time we pick this up, we can have a little bit of something to go off of. So let me do that before it gets any later. So need to modify the geometry structure functions. Seth, thank you so much for the follow. I appreciate it. To allow for multiple materials. And then we also need to write shader to handle 8 material weights blending, which we've already kind of a little bit started that. We want multi-materials, perhaps. Combine maps using UV offsets. Let's see, what else do we need to do? We need a way to load terrain configuration from file. We obviously need to load height maps. Calculate normals, tangents. This is going to be a copy pasta of existing, but using terrain vertex structure. I think that is more or less it for now. I can't think of anything else that I'm missing. Okay. So yeah, this is going to get interesting here. In fact, actually, this isn't what's going to have to change. It's going to be the material system that's going to have to change. Actually, that kind of brings up something else. New material type, terrain multi-material. Are you making a game engine? Yes, I am. I'm writing one completely from scratch with no libraries, with the exception of these two right here, which is STB image and STB true type. Yeah, we are making a game engine here. So let me comment this out. To do acquire materials. What? Oh, it's a U16. I used the wrong type there. U16. Looks like we got a couple things here going on. Oh, material index. This is... We changed that to material weights. And that was an array, right? It is. I guess we'll just mem set this, basically. 0 memory, obviously. Material weights, size of F32 times that. And then the material weights sub 0 is going to be equal to 1.0f, just so that we have something to start off that's kind of valid. Why is it still bleating about that? Let me build. What else did I forget? Renderer create geometry. Oh. Must not have included the renderer. Renderer front end. All right. So just to show you kind of where we're at with our game engine, we have the ability to define scenes that we can kind of load up. So it's nothing fancy just yet, but you know, we do have some basic lighting and normals and whatnot, and the ability to load geometries and so forth. So what we're working on right now is basically getting terrain working, right? So we've just started developing that, actually. But I think for tonight, this is probably as far as we're going to get, because we kind of did a lot of discussion in terms of design and the way that the terrain is going to work. So I've got some notes here to come back to on the next stream so that I know where to pick up. And I'm going to do some thinking, probably off camera, about a couple of these things that I've got question marks here of how I want to approach these things, because there's about a dozen different ways that we could approach it. And I just want to pick one that is either the best approach or at least going to get us up and running in such a manner that we can actually refactor it later. So, all right. Let me get status. What branch are we on? We are on main. So I'm going to create a feature branch. check out B feature terrain. I'm going to put this up there so that you guys on the repo can see the code changes that I've made thus far. And obviously, since this is a new feature, we're going to keep it on the feature branch until the terrain is complete and working. And then we will go ahead and merge that into main, just like we did for the last thing that we put in, which was the scene loading. So let me just add all of this stuff. Initial commit for terrain structure. Functions. Whoops, push u origin feature terrain. All right, so now this stuff is all up on the repo. So it's just github.com/TravisRoman/Kohi if you're looking to see kind of what this is. If you're interested to know a little bit more about the engine, this project, and whatnot, we do have a website, KohiEngine.com. There is a frequently asked questions. There is a forum. We don't use it all that much. There is auto-generated API documentation that we have. And then there's a little bit of information here about the game engine, the project, some of the goals, things like that. We do have a Discord server, so feel free to jump into that as well. There's a link to GitHub. There's a link to Patreon. And then here are the latest YouTube videos. All of the videos or all the streams that we're doing here get uploaded onto the YouTube channel. So I'm just going to kill that real quick. And we will go here. So here's the YouTube channel, right? So I've got this Vulkan Game Engine series playlist with everything that we've done so far, right? So all of that is there, and all of it is accessible from KohiEngine.com. So I hope that is useful. I am going to update that site sometime soon, I think, with some new stuff. But, you know, for the time being, it is what it is. All right. Anyway, I think that is going to pretty much do it for tonight. So let me see. I don't see any game dev peeps on tonight. So I'm going to raid Ferret Software again. For those of you who are familiar with Ferret Software, it's basically it's a channel dedicated to ferrets. And they typically just like are playing around in their cages or sleeping, whatever. They are owned by Pirate Software, who's a game dev. He's doing some pretty cool stuff. He's making a really cool game named Heartbound, but he has this second channel for his ferrets, and all of the ad revenue goes towards taking care of them and making sure that it pays for their food and their medical care and stuff like that. And it's just cute to watch them, right? So I'm going to go ahead and raid Ferret Software. And yeah, so I think next time we'll pick up where we left off as far as this is concerned, and hopefully we'll actually be getting something on the screen, at least, our flat plane of terrain stuff here somewhat shortly. We've got a lot of work to do around the shaders and material system, and that's what we'll spend doing the next stream. So I just want to thank you guys so much for coming along and joining me here and interacting with the stream and following. And of course, I always appreciate the follows, the likes if you're watching this on YouTube, the subscriptions, all that stuff. That all helps support the channel. So thank you guys very much for that. And yeah, I will see you guys next time. See ya.